Algebra 2, Section 7-2, Solving Exponential Equations and Inequalities. So here is my example I'm going to start with. If 3x equals 3 to the 5th power, then x equals 5. And so what I mean by that is that if the base is the same, you can kind of just ignore the base if it's the same, and you can look at just the exponents, and you can solve your equation by using the exponents. Let's see what I'm talking about here. We're going to do several examples. 2 to the x power equals 8 to the 3rd power. Okay, I want these bases to be the same. I know that 8 is 2 to the 3rd power. So 2x equals 2 to the 3rd power to the 3rd power. So what I've done is I've just taken this 8 and rewritten it in a different way. 2 to the 3rd power is the same as 8. These are the same thing. I just have rewritten it in this factored form. And so now I have to take these two 3's and do something with them. So I have to remember, do I add these or do I multiply them? 2x equals 2 to the 9th power. I multiply them because it is, I'm raising it to this power. If I was multiplying across, then I would add them. But since I'm raising it to the 3rd power, I multiply them. So 2x equals 2 to the 9th power, x equals 9. Let's do another one. 9 to the 2x minus 1 equals 3 to the 6x. Okay, I want this 9 to be a 3. So 9, if I were to rewrite this with a base of 3, it would be 3 squared. Okay, so 9 becomes 3 squared, but it still has this 2x minus 1 equals 3 to the 6x power. So now, remember, if I raise it to another power, I've got to multiply. So these exponents need to be multiplied. So 2 times 2x and 2 times negative 1. So I've got 3 to the 4x minus 2 equals 3 to the 6x. Now I can ignore these 3's, and I can just say 4x minus 2 equals 6x. Since the bases are the same, I just ignore them. I'm going to subtract 4x from both sides. I get negative 2 equals 2x, divide by 2, and x equals negative 1. Whew. All right, let's do another one. Actually, let's do, well, no, let's not do it that way. Let me show you another way you can solve this same one here. 9 to the 2x minus 1 equals 3 to the 6x. I want this 3 to be 9 this time. So this last time I made the 9 3. This time I'm going to take this 3 and make it 9. And the way I do that is I need to take 2 out of here. So 9 to the 2x minus 1 equals 3 squared. And then in order to get 3 squared out of here, I've got to have it to the 3x. So when I multiply 2 times 3, I get 6. And so I needed to divide that 2 out of that 6 in order to put it here. And so now I have 9 to the 2x minus 1 equals 9 to the 3x. Now I can ignore the 9's. 2x minus 1 equals 3x. Subtract 2x from both sides. I get negative 1 equals x. Same answer, different way of getting it. Either one, whichever way makes more sense to you, use that way. It doesn't matter to me. As long as you are mathematically correct, then I'm not worried about which way you like to use, which way makes more sense to you. We're going to do a few more examples here. 4 to the 2n minus 1 power equals 64. We're going to do this one together, then I'm going to give you 2 U tries to do on your own. All right, so 64, this is 4 times 4 times 4, right? So 4 to the 2n minus 1 equals 4 to the 3rd power. 4 times 4 is 16. 16 times 4 is 64. So now I've got the bases are the same. I can ignore them. 2 minus 1 equals 3. Add 1 to both sides. 2n equals 4. Divide by 2. N equals 2. All right, I'm going to give you 2 to do on your own. 5 to the 5x equals 125 to the x plus 2. And 2 to the 5x equals 4 to the 2x minus 1. Okay, so these we can put these in parentheses if that makes it easier. All right, do those 2, and let's see how you do. All right, let's see what you got. I've got 5 to the 5x equals, okay, so 125 is 5 to the 3rd power. 5 times 5 is 25, times 5 is 125. So 5 to the 3rd power raised to the power of x plus 2. So I'm going to distribute this 3 in there, because this 5 to the 3rd is being raised to this power. So 5 to the 5x equals 5 to the 3x plus 6. Now, I can ignore the 5 in the base and just say 5x equals 3x plus 6. Subtract 3x from both sides. 2x equals 6. Divide by 2. X equals 3. Let's do this one. Let's see, I'm going to change this 4 to the base of 2. So 2 to the 5x equals 2 squared, which is 4, raised to the power of 2x minus 1. Distribute this 2. 2 to the 5x equals 2 to the 4x minus 2. Ignore the 2's. 5x equals 4x minus 2. Well, the 2 is in the bases. I'm not going to ignore that 2, right? That's part of what we're working on. Subtract 4x from both sides. X equals negative 2. All right, next thing we're going to do here is write an exponential function. Okay, here's an example. We're going to start with 7,500 bacteria cells. Four hours later, we have 23,000 bacteria cells. What? In only 4 hours, we've gone from 7,500 to 23,000 cells? Crazy. Okay, here's what we're going to do. We're going to try to write this in exponential form. So we're going to start with y equals a times b to the x power. Okay, so a is our initial amount. So we know that that's going to be 7,500. All right, now what we need to do is try to find out what is b. That's our issue here. What we're trying to find is b. Just similar to when we're trying to find the b value or the y-intercept. This is a different b. That's not the same y-intercept that we were talking about, but it's still kind of the same idea, where we have certain information and we want to find b. Okay, here's how we do it. Let's rewrite our equation. Y equals 7,500 times b to the x power. Here's what we know. 4 hours, we have 23,000 cells. We know this is the initial amount because that's what we started with. And so when x is 0, y is this much. That's why that's the initial amount. When x is 0, then this whole thing becomes 1. 1 times 7,500 is going to be 7,500. Okay. So we know it's the initial amount. Now, here is our other point. Our other point is 4 hours later, we have 23,000 cells. So now let's plug this point in to this so that we can find out what b is. So here's how that works. We have 4 as our x value and 23,000 is our y value. So 23,000 equals 7,500 times b to the 4th power. So I just plugged in my y value and my x value. Now I need to solve for b. So I'm going to divide both sides by 7,500. And when I do that, I get this kind of nasty 3.067 equals b to the 4th, because those go away, right? So now what I need to do to get this b to the 4th to be just b is I need to take the 4th root of both sides. So when I plug the 4th root into this 3.067, the 4th root of that into my calculator, I get 1.323 is approximately what b is. Okay, so I found b by plugging this into my calculator. So this is asking me, write an exponential function. So it didn't ask me to find b, it asked me to find my exponential function. Here is my exponential function. Y equals my initial amount times b, which is 1.323 to the x power. There is my exponential function. Okay, let's try, let's have a u try. I've got 3.2 million cans in 2005. This is a recycling plant or something. In 2010, we destroyed, just something, 420,000 cans. All right, so we have in 5 years a big change from 3.2 million to 420,000 cans. So see if you can use this information to write an exponential function. All right, go. What? How am I supposed to do that? Well, let's try it. Okay, so my initial amount is 3.2 million cans, and that was in 2005. So that's going to be my 0. When x is 0, y is 3.2 million. All right, so my initial amount is 3.2 million times b, which I don't know, to the x power. So now I just need to find b. And what I'm going to do to find that b is I'm going to take this and I'm going to take this. This is my other point. Now, I don't use 2010 because I didn't start at 0. I started at 2005. So my x value is 5 and my y value is 420,000 cans. So I'm just going to plug in 420,000 equals 3.2 million times b to the 5th power. So I divide both sides by 3.2 million. 3.2 million. And so I plug that into my calculator. Can I plug all of those numbers into my calculator? Let's see. So I say 420,123 divided by 3.2 million. So that's 3,200,000. Did I get that right? Get enough zeros in there? 5 zeros. Okay. So I should have, then I'm going to move this over here, 0.13125 equals b to the 5th power. So now I take the 5th root of both sides. So let's say second answer to the 5th, let's see, 5th power of 5th root of 0.13125 equals, so that means b equals, I'll do it, it's approximately 0.67. Okay, so that's my b value. So now I just need to find some space to write my answer here. My answer to this equation, or the exponential function here, is y equals 3.2 million times 0.67 to the x power. That's it. All right, let's do a couple other examples. Another U-try. In the year 2000, the population of Phoenix is 1,321,045. By 2007, they estimate that they will have 1,512,986 people. Now, predict. So first, we need a function. So find the function. And then we need to predict the population in 2013. Okay, so we got one more chance to write the function, and then let's predict the population for 2013. So let's bring the b value to 4 decimals. Okay, go ahead and write your function, then predict the population for 2013. Go. Okay, let's see how you did. So in 2001, we're going to call that 0. The population was this much. So I'm going to say y equals 1,321,045 times b to the x power. Now, 7 years later, that's my x value, 7. We're estimated to have this y value here. So I'm going to plug that in for y and that in for x. And so when I do that, I'm going to have 1,512,986. Divide both sides by 1,321,045 equals b to the 7th power. Hopefully that's not too confusing what I just did. I just divided this from both sides, but I didn't want to write it all out, so I just did it like that. So now what I'm going to do is I'm going to take the 7th root of both sides of this. 7th root, 7th root. So on my calculator, I'm going to type 7, and then I'm going to do second, and then this little x guy with the radical, and then I'm going to put in it parentheses 1512986 divided by 1321045 end parentheses. See if I typed all that in right. 1512986. Okay, that looks all good. That all looks good. Equals. So B is approximately 1.019697. Should be 97. Okay, so my function is going to be y equals 1,321,045 times 1.0197 to the power of x. All right, so you should have gotten that for your function. Now I need to predict the population in 2013. So all I have to do is I say this was 2000, and so I subtract 2000 from 2013, and I just say my x value is 13. I need to know what y is when x is 13. So I just go like this. I take this number, so I'm just going to actually just circle this 13 and write an arrow like that, so I don't have to rewrite everything. So I'm going to go 1.0197 raised to the power of, oh, that's not going to work. I have to do it this way. Okay. 1.0197 raised to the power of 13. Oops. Raised to the power of 13, and then multiplied by all of this, and you're going to get 1,700,221 approximately. Raised to the power of 13. Let's see if I can. Oh, and then multiply by 1321045. All right, so when I plug this into the calculator, last time I had used 96 because we did some rounding over here. And so this time when I plugged it in, I actually got 1,702,390. So this is what I got when I used. Isn't that crazy? Just that difference between 6 and 7 right here. 2,000 people. Pretty crazy. All right, the last little bit here is compound interest. Compound interest. Another formula, A equals P times 1 plus R over N to the power of N T. Okay, A is the total, P is the principal or initial amount, R is the rate or annual rate as a decimal, N is the number of compounds per, or periods, compound periods per year. So we're talking about years. It could be different than years, but generally it's just years. So we're just going to keep it that way. And then T is the number of years. Typically, compound interest works in terms of years. So that's where we're going to leave it. You could use this formula in a different way, but we're going to keep it as years. So here's one example. We're just doing one example. So this account pays 4.2% annual interest. And it's compounded monthly. So you're going to start, your initial amount is $2,500. How much will you have after 15 years? All right, so let's talk through this. Change my pencil out. My total is going to be, my initial amount or my principal was $2,500 times 1 plus my rate, which is 4.2%. I need to move that over to make it a decimal, 0.42, over the number of times it's compounded. It's monthly, so in a year there are 12 months. It's compounded 12 times, times n times t. So n is, again, 12, and t is 1, because it's just 1. Oh, no, 15. Sorry, 50, after 15 years. So we're going to say 15. Now I just need to carefully plug all this into my calculator. So it can be kind of a mess to get this through your calculator the right way, but take your time. Maybe find this and then raise it to this. So let's just go through it on the calculator. Okay, so 12 times 15. Let's do that first. Oops. 12 times 15 is 180. So this is 180. Okay, so that makes it a little bit easier. So now I'm just going to do this. So 0.042 divided by 12. 0.042 divided by 12 is 0.0035. Okay, I'm going to add 1 to that. Add 1 equals 1.0035. Then I'm going to raise that to the power of 180. So I go, I do my little caret, and then I push 180. Once I do that, then I get this number here, 1.875546. Okay, then I'm going to multiply that. I've done all of this mess. Now I'm going to multiply that by 2,500 times 2,500 equals $4,688.87. So after 15 years, with this type of compound interest, 0.042, you could make almost double your money in 15 years. Pretty good. And that is 7-2. Do a good job on your homework.